हेलो गाइस। अभी तो हॉटस्पॉट पे स्ट्रीम कर रहा हूँ। I'll tell you the reason. Am I audible? Let's check भाई, let's check. हेलो हेलो गाइस। अभी तो हॉटस्पॉट पे स्ट्रीम कर रहा हूँ। I'll tell you the reason. Okay, fine. We are so back at the stream guys. आज हम करने वाले actually I'll tell you, कल तो मैंने बहुत आलस किया। आज एक्चुअली क्या हुआ कि फटीग था। डेफिनेटली ये मेरा एक्सक्यूज है भाई। आई एक्सेप्ट, ये मेरा एक्सक्यूज है एंड आई एम वर्किंग, आई वर्क ऑन इट। ओके एंड हाँ, फिर आज मैंने कॉलेज में क्या किया कि कॉलेज में एक्चुअली हमारा फ्री टाइम ज़्यादा होता है, कल नहीं है बट यूजुअली बहुत ही ज़्यादा होता है। तो मैंने एस टी एल का गुड अमाउंट कंप्लीट किया एंड जब हमने कैरेक्टर हैश छोड़ा था, कैरेक्टर हैश मैंने थोड़ा सा कंप्लीट किया, तो एंड एस टी एल आधा किया। सो आज टारगेट रखता हूँ कि एस टी एल कम्प्लीट करूंगा एंड देन कल कैरेक्टर हैश कंप्लीट करेंगे। स्ट्रीम आई गेस ज़्यादा बड़ी नहीं होगी। इट्स जस्ट माई मार्क की आई वॉज कंसिस्टेंट दिस डे ऑल्सो। ऑल तो उतना आउटपुट नहीं निकाल पाया मैं, लाइक बट स्टिल आई वोंट टॉक एनी सेल्फ नेगेटिव। आई हैव माई गुड डिसएडवांटेजेस एंड इम्प्रूवमेंट्स। सो विद दिस लेट्स स्टार्ट द स्ट्रीम।
And you would have learned about something like math.h. So in order to include all the algorithms in math library, you have now the next container. In vector we did learn about erase, start, comma, end. Similar thing also works over here. If you want to erase everything, yes, if you want to erase everything between 2 and 4, imagine you had something like this. So 2 is here, 4 is here. If you get the first guy, if you get the second guy, so if you do find, you'll get the 2's iterator. If you do find a 4, you'll get the 4's iterator. So it deletes 2 and 3. Remember this, it deletes 2 and 3, not 4. 4 is this bracket and this is this. Please remember this. Now in set, there are other functions like size, empty, swap. Everything is similar to vector. There is begin. All of these are
मैं बहुत एक्सक्यूजेस ढूंढ रहा हूँ, पता है आजकल। लाइक अभी दोपहर को क्या हुआ कि मेरा लैपटॉप फ्लिकर मारा तो मेरी तो फट गई भाई। मैंने सोचा कि नहीं नहीं, अब मेरे को रिपेयरिंग को देना पड़ेगा या ब्ला ब्ला। मैंने अननेसेसरी स्ट्रेस इतना लिया कि फिर मैंने लैपटॉप पे काम ही नहीं किया भाई। फिर मैं कुछ अलग ही करते बैठ गया। मैं कोई मूवी देख रहा हूँ अभी रूममेट के साथ बैठ के, एक साथ बैठ के कम्युनिटी रील देख रहे हैं भाई। मैं अपने फ़ोन पे स्क्रॉल कर रहा हूँ, हम दोनों हाथ दांत निकाले जा रहे हैं। या थिंक मेरे को वो थोड़ा छोड़ना पड़ेगा लाइक मेरे दिमाग में ये भी था कि लैपटॉप नहीं चला तो मोबाइल में देख लूंगा, बट क्या पता भाई। सो वर्स्ट के सिनेरियो इज कि शायद मैं रिपेयरिंग को लैपटॉप दे दूँ। लेट्स सी हाउ इट वर्क्स। दिस इज फॉर इरेज।
similar to vector. So I will not be explaining them.
सोने का
The
टाइम
most
होगा बट
important are
कंप्लीट करके
find,
तो नहीं सोऊंगा।
count, and insert. These are the most important ones, and as well as erase. Now they have something as a lower bound and an upper bound. So I will be linking a video in the description which explains lower bound in depth and upper bound in depth. So please go back and watch lower bound and upper bound. Once you have seen that, you will actually understand how does this lower bound and upper bound work in a set. It's the exact same that will be
बोलो कि
taught in
लोअर
the
बाउंड
video
अपर
which
बाउंड
is
का देखो।
in the description. So please make sure you watch it. Now in set, everything happens in logarithmic time complexity. If you're inserting, it takes logarithmic. If you're erasing, it takes logarithmic. Everything happens in a logarithmic time complexity. Again, if you don't know login, no issues. Please remember this in your head. Now we did learn about set, and I said sorted and unique. That means it will just contain one occurrence of two. You can insert thousands of occurrences of two, but it will just store one occurrence of two. But there is something as multi-set. If you define multi-set, it only obeys sorted and it will not obey unique. It will store multiple occurrence. Like if you try to insert one, 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 stores all the occurrence. And if you try to erase one, but all the occurrences are erased this time. But if you do an erase one, it erases every one. And this time count will count you the number of ones in the multi-set. But if you want to delete, imagine your multiset is containing three ones, and I just want to delete one occurrence of one, or two occurrence of one, or three occurrence of one. So what I can do is I can just find out the first occurrence of one. So I'll just do multiset dot find because I know find points to the iterator, and I'll say erase that iterator. Instead of saying
Wait,
three
wait, wait.
occurrences are erased this time, all the occurrence. And if you try to erase one, but all the occurrences are erased this time. But if you do an erase one, it erases everyone. And this time count will count you the number of ones in the multiset. But if you want to delete, imagine your multiset is containing three ones. And I just want to delete one occurrence of one, or two occurrence of one, or three occurrence of one. So what I can do is I can just find out the first occurrence of one. So I'll just do multiset dot find, because I know find points to the iterator. And I'll say erase that iterator. Instead of saying erase element, because if I say, understand, if I say erase element, it erases all the elements. But if I say erase address, it only erases that portion. It only erases that portion. And I want to erase like two ones. So I say find one and go till two. Go till two, so it will erase both of them. Both of them. So either erase element, erase address, or erase
मैंने
starting
मल्टी
address
सेट किया था.
and right after the end. That's it. The iterators.
And ये भी एड्रेस है.
And rest all functions are same, like 111 to definition of as unordered set. Everything is similar to set. The only thing that is omitted, like it stores unique, the only thing omitted is it does not stores in the sorted order. We don't know how it will store. It has randomized order. It has randomized order. Like if I put in 1, after that I put in 5, after that I put in 2, after that I put in 3, after that I put in 6, it can have this order, it can have any order in the world, but it will just have unique elements. Like if I try to insert 1 again, it will say I have 1, I have 1. And in most of the cases, the time complexity is big O of 1. Everything, like all the operations are same. Insert, erase, all the operations are same, but only the lower bound and upper bound function does not work. All the operations work, but the lower bound and the upper bound functions do not work. Remember this, all operations are similar to set, and they do not store everything in sorted order. Most, if I try to it have randomized order, it has randomized order. Like if I put in 1, after that I put in 5, after that I put in 2, after that I put in 3, after that I put in 6, it can have this order, it can have any order in the world, but it will just have unique elements. Like if I try to insert 1 again, it will say I have 1, I have 1. And in most of the cases, the time complexity is big O of 1. Everything, like all the operations are same. Insert, erase, all the operations are same, but only the lower bound and upper bound function does not work. All the operations work, but the lower bound and the upper bound functions.
Hold on. I don't think so. I don't think so. I don't think so. Think so.
Do not work. Remember this. All operations are generically once in a millennium. Like if the data is explore the woods for a Vigo opens, you will understand these things when you move across or when you grow in experience. That's how the unordered set works. So the next container that we will be learning is a map container. Okay. Now you can think this as something like just take a task where I say in your college there will be like there might be multiple people with Raj name, but how do you distinguish themselves? By roll numbers, right? One Raj might have a roll number of 23, the other Raj might have a roll number of 25, the other Raj might have of 28. So you know this one guy is of roll number 23, the other guy is of roll number 25, the other guy is of roll number 28. So generally this is in your class this is stored like this: roll number 1, roll number 2, roll number 3, and so on. If there are 50 people, you store it like this. So map, you can think this as a data structure or a container which says the roll number is my key, and over here the value can be the name. So this is what the data structure means. You store unique keys because you can't have 23 roll numbers twice. You can have it just once. So the keys are unique. The keys are unique, but the values can be like over here there can be a Raj, over here there can be a Raj. So there is one guy with key 3 who is Raj, there is one guy with key 50 who is Raj. There can be duplicate values, but it has to be a unique key. So you can think map as a container which stores everything in respect of key and values. And very important thing, this key can be of any data structure. It can be integer, sorry, any data type. It can be integer, it can be double, it can be pair, it can be anything. Similarly, this value can be anything. So how do you define map? This is key, this is value. Key is integer, value is integer. Over here, key is an integer, and they're saying value is two integers. Over here, they're saying key is two integers and value is one integer. So you can define it as you wish to, that is on you. This is how you define. Okay. Now, if I'm defining the map to be this, for an example, assume you're defining the map to be this. Now, I say 1 equal to 2. It means on the key 1, can you please store 2? So this is what it stores internally in the map. Internally in the map, it stores 1 comma 2. Next I say, I don't want to store it like this. Emplace 3 1. So it stores 3 is the key and the value to 3 is 1. It does a similar thing, stores it in and stores all these three variables 2 comma 4, and this is how you can store all these three variables. Okay, so in this way you can actually store for this particular declaration. And remember one thing, map stores unique keys, very very important. Map stores unique keys in sorted order, something similar to set data structure. Map stores unique keys in sorted order, something similar to set data structure. Okay, now this is the declaration, the second declaration. For this declaration, sorry, this declaration, this is the key. So you have declared the key like this, and the
स्ट्रीम चल रही है ना भाई, स्ट्रीम चलनी चाहिए, चल रही है अभी, better FPS. Audible, am I
structure. Okay, now this is the declaration, second declaration. Value is a single integer, so this is it. For this, it will be storing like, okay, key is 2 comma 3, so this is stored, and the value, corresponding value is 10. Perfect. So this can be stored like this. That's how it generically stores. Okay, I hope that makes a lot of sense. I told you that everything is stored in a sorted order. So this will at first store a lot, one by one, explore, or if you want to iterate on the map, similar in the vector, it stores in a plus. You say it, you run a for each loop. First time it is here, so it stores in a pair. Next time it is here, stores in a pair. Next time it is here, it stores in a pair. If it is storing in a pair, this is it dot first, and this is the it dot second. So first time prints 1 2, next time goes here, prints out. This is how you can actually traverse in a map, and everything is stored in a sorted, or you time 1 2 first in a pair. Next, first time id in the vector. All you do is you say it, you run a for each loop. First time id is here, so it stores in a pair. Next time id is here, stores in a pair. Next time id is here, it stores in a pair. If it is storing in a pair, this is it dot first, and this is the it dot second. So first time prints 1 2, next time goes. So if you try to do this see out, this is how you can actually traverse in a map, and everything is stored in a sorted order of key. In a sorted order of key, not stores one. If I want key, remember this, sorted key is how it stores, no duplicates, all uniques. Okay, now if I want to access map of 1, if I want to access map of 1, it says a value 2. Well, it says if I want to access map of 1, it says a value 2. It says a value 2 because at 1 you're storing 2. But if it tries to access 5, will it find 5? There is no 5. So what happens? It says null. But if you want to print it, it actually goes and prints 0 or null. Okay, because it does not exist. So if something does not exist, it gives you 0. Okay, so this is how you can easily access.
यार कौन मैसेज किए जा रहा है यार? Aggressively.
For a key. Now, if
Well, एक मिनट.
If you wanna know the iterator, imagine you want to know where the key to lies, the address of it. So again, the find function will come over here and say map.find3. So this is where you get it, the iterator. In order to access this, you give a star. So this accesses this. And if you want the value, dot second. Got it? It gives you the iterator to the this 3 comma 1. Okay, this it is this. So if you give a star, it's the element, and if you give a second, it is the one. That's how you can easily access this as well. Now over here, second, it is the one. That's how you can easily access this as well. Now over here, if you try to do dot find 5 and 5 is not there, it points to nothing but dot and means after the map, after the map. Okay. Makes sense? And again, the lower bound and upper bound functions, if you have seen the video in the description, you can understand how lower bound and upper bound works. Okay. And all the other functions like erase, swap, size, empty are same. So I'm not going to explain it again. Next thing is multi-map, similar to map. Only thing is you can store duplicate keys. You can store duplicate keys. Something similar to set and multi-set, as I told you, right? Duplicate keys, but everything in the sorted order. This time you can store like 1 comma 2, and then you can come across and again store like 1 comma 3, right? So you can store duplicate keys over here. Unordered map, again, unordered map is similar, only this portion will go across. It will not store in sorted. It will be randomized. It will be randomized, but it will it will not have duplicate as well. It will just have unique keys. Unordered map will have unique keys, but it will not be sorted. And the difference is like the map works in randomized. Only this portion will go across. And again store like 1 comma 3, as I told you, right? Duplicate keys, but everything in the sorted order. This time you can store like 1 comma 2, and then you can come across and again store like 1 comma 3, right? So you can store duplicate keys over here. Unordered map, again, unordered map is similar, only this portion will go across. It will not store in sorted. It will be randomized. It will be randomized, but it will it will not have duplicate as well. It will just have unique keys. Unordered map will have unique keys, but it will not be sorted. And the difference is like the map works in logarithmic of time, and the unordered map in almost all cases works in constant time. In the worst case, it goes for big of n. Again, this worst case happens once in a blue moon, not always. In almost all the cases, big of 1 is what appears. So as of now, I can say that I have completed containers and iterators. Now this is not required, not required. No need to learn it. Just omit this. Now I'll be telling you all the important algorithms, like which are mandatory, like you should know, and all the other algorithms which I will not teach. You will eventually learn while you code. That are not like those are not important. So as of now, you can just leave it. Eventually, with time, if it's required, learn 3 2. Okay. So let's move across to learn some algorithms. Now, if I say you that, hey, listen, I give you an array of size like 1, 5, 3, 2. Okay, of size 4, and I want you to sort it. So you will be like, let's apply bubble sort, merge sort, selection sort, so and so. But in C++STL, if you just write the line sort a comma, it's a 4 size. So this actually means the first position of the first iterator, the starting iterator, and this means the last iterator. A plus 4 actually means this portion, then portion, the last iterator. Again, similar to something like start is included and end is not included. So you write the starting iterator, which is a, which actually points to this, and a plus 4, which actually points to this. So all the elements are sorted. Right after this line, it will have 1, 2, 3, 5. So you don't have to actually use merge sort, bubble sort, selection sort. It sorts that into one line. And if you're using vector, the starting is begin. This is the ending, the starting iterator and the ending iterator. So in this way, you can sort any container, not map, all not map. I'm talking about vectors and arrays over here. Okay. Now, what if I just wanted, like, I had something like 1, 3, 2, 5, and rather, let's keep it like 5, 2. Okay. And I wanted just this portion to be sorted. So I know a plus 2, because this is a plus 2 for sure. And I know a plus 4, right after this is a plus 4. So only this portion will be sorted. So this is how only this portion will be sorted. Perfect. What if I want to sort them in descending order? Imagine you have like 1, 3, 5, and 2. I want to sort them in descending order. So it's very simple. Give the starting iterator, give the ending iterator, the portion that you want to sort, and just write greater int. Yes, just write greater int. And this is nothing but a comparator, an inbuilt comparator, which automatically sorts it. Like I'll teach you comparator, automatically will sort it in the descending order like this, in a descending order. You just need to write greater int, and it automatically sorts it into a descending order. Now, what if I want to sort it in some other fashion? Because as of now, we know how to sort it in increasing, we know how to sort it in decreasing. But what if I want to sort it in my way? Because going across, you will see that this my way is being used a lot. For an example, we have declared a pair array, and these are the pairs 1, 2, 2, 1, 4, 1. Okay, and I want you to sort according to second element. Like I want you to sort it in order of increasing second element. Please understand. I want you to sort it according to increasing second element. Okay, and if the second element is same, then sort according to the first element, but in decreasing. But in decreasing. What do I mean by that? So as of now, can I say the second element is 2, 1, and 1? So this 2, comma 1 and 4, comma 1 are the guys who should appear right at the first. Okay. This 2, comma 1 and 4, comma 1 are the guys who should appear right at the first. Okay. Because the second elements are 1 and 1. And after that, I can say after that, 1, comma 2 will appear because of this portion. So can I say that I've sorted according to the second element? But I still have a problem. Now these
Yep. So with this guys हो गया STL का लेक्चर खत्म. डिसेंडिंग ऑर्डर है एंड वो भी वो रिलेवेंट नहीं है. So with this, yeah, the my stream is officially becomes over. What I want to talk with you guys is कि भाई okay, let's turn this off. Like not to you guys specifically, to myself, भाई, to my own lazy self. यार, so what I was saying कि slowly I'm getting to feel कि my motivation to do anything in my life is just going down and down and down and down. Like ऐसा मुझे feel हो रहा है. भाई देख, I'm not saying it's fucking depression or something. मे बी मैं हर चीज में ज्यादा स्पार्क ढूंढ रहा हूँ, जैसे लाइक वी ऑल सी ऑन इंटरनेट की ओ भाई लाइक फॉलो योर पैशन टाइप शिट. बट आई नीड टू एक्सेप्ट कि अभी मेरा पर्टिकुलरली कोई पैशन नहीं है. एंड दिस phase which is going is definitely a difficult phase. Like I read something ki, like I read somewhere something ki the most difficult thing is to change. The reason is that you fall in love with your old self so much that you start hating your new self. So we just have to overcome this hate. See भाई, मेरा तो एक ही है, मैं पता है कि आई वांट टू गेट टू लॉजिक फेमिलियर. मतलब यार क्या पता, मुझे ना लॉजिक से बहुत रिपेलेंस है. एक बहुत ही आई कैन फील इट भाई. देख, आई टेल यू, इवन इफ आई टेल यू कि भाई मेरा ना मैथ्स में ही पॉइंटर कम है एंड बाकी सारे मतलब जितने भी सॉल्विंग वाले पेपर्स हैं ना इन माई इंजीनियरिंग, उसमें मेरा मैथ्स में ही सबसे ज़्यादा कम है. एंड आई ऑलवेज वंडर कि मैं इतना मतलब सी मुझे खुद पता है कि मैं कितना पढ़ता हूँ. एंड आई फील कि जितना मैं पढ़ रहा हूँ, जितना मैं एफर्ट डाल रहा हूँ, उससे ज़्यादा मुझे आना चाहिए। फॉर एग्जांपल मेरे को आते 50 में से 30 मार्क्स, तो आई एक्सपेक्ट कि एक पेपर से पहले एंड पोस्ट पेपर में ये एक्सपेक्ट करता हूँ कि बेर मिनिमम 36 37 आ जाए। ऐसा लाइक मैं एक्सपेक्ट करता हूँ। बट द थिंग इज मैं पेपर में फंबल हो जाता हूँ, रीजन मीन आई एम नॉट फेमिलियर विद द लॉजिक। आई एम नॉट जस्ट भाई, मैं तो ऑनेस्टली बोल रहा हूँ, मेरे को वो फेमिलियरिटी लेनी है खुद में। भाई ये आंडू पांडू सिचुएशन जैसे कई सोशल गैदरिंग, सोशल सिचुएशंस, वो सारी हैंड हो जाते हैं, पता है इसमें लॉजिक नहीं लगता। लाइक आई हैव सीन पीपल सेइंग कि यार ये चीज़ अच्छी है तो इसमें लॉजिक नहीं भाई। मैं बोलूँ जब तक मैथ्स, अगर मैथ्स नहीं आता एंड किसी मल्टीपल चीज़ों में तो ये रिलेशन ढूंढने नहीं आता एंड एक्सेट्रा, भाई नहीं है भाई, लॉजिक अच्छा नहीं है। और मुझे खुद में यही एक डेवलप करना है, सी आई वांट टू बिकम, आई वांट टू बिकम प्राउड ऑफ माई सेल्फ भाई। एंड आई नो इट विल टेक अ गॉड डैम टाइम। लेट्स एग्री टू दिस एंड आई विल डू इट भाई, आई विल डू इट। इट्स जस्ट स्टार्ट। नथिंग इन दिस वर्ल्ड कैन स्टॉप मी भाई एट एनी कॉस्ट। मैं घिस दूंगा भाई, मैं नहीं सोचूंगा कि लाइक ये बंदा मेरे से अच्छा कर रहा है या फिर, सी भाई, द थिंग इज अभी मैंने इस चीज़ के लिए लव डेवलप नहीं किया है। कुछ कुछ बोलते हैं लव ऑफ द गेम, कुछ कुछ बच्चे जेनुअनली उनको कोडिंग इतनी अच्छी लगती है भाई, मतलब बट दे आर फॉर द लव ऑफ द गेम भाई। मैं मैं उन्हें तो कभी नहीं हरा सकता भाई, कम ऑन। बट एटलीस्ट आई कैन बी माई सेल्फ, ऑनेस्टली टेल, मुझे नींद बहुत अच्छा आने लगी है आजकल। आई कैन स्लीप वेरी वेरी वेल बिकॉज मुझे पता है क्या, दिन में कुछ ना कुछ तो किया है भाई, कुछ ना कुछ तो किया है। नो डाउट मेरी पास्ट की मिस्टेक्स भी रिपीट हो रही है, बट बैड हैबिट्स भी रिपीट हो रही है, बट इट्स फाइन भाई, दैट आई हैव डन समथिंग गुड एंड legitimate with my this part of the day. That's it. So yeah, that's it for today, guys. I'm planning for a good. Oh wow, my triceps. कुछ खास नहीं है, जैसा ना, हाँ nothing special I believe. Anyways, so yeah, आज के लिए इतना ही काफ़ी है। रिश्ते में तो हम तुम्हारे बाप लगते हैं, बट नाम है हमारा एंटी आयुष। ओ 01 बाय।